Hello everyone, welcome back to the FT Share channel. In this video, we are going to discuss the rival of the turbocharger, a forced induction system that is commonly installed in muscle cars, namely the supercharger. The supercharger is a force induction technology discovered by G. Jones in 1848. Thus, the supercharger was discovered before the turbocharger. The function of this device is to increase the air capacity and airflow in internal combustion engines, with the goal of providing more oxygen so that the engine can process more fuel more efficiently. And of course, this results in more power compared to standard engines that do not use forced induction systems. There are several types of superchargers in the market. The first one is the Roots supercharger, the second one is the Lysholm twin-screw supercharger, the third one is the sliding fan supercharger, the scroll-type supercharger, and finally there is the centrifugal supercharger. Here, we won't discuss all these types of superchargers one by one because the goal of all these superchargers is certainly the same, which is to introduce the principle of force induction system into superchargers. Therefore, we will use the most common type of supercharger available on the market, namely the Roots supercharger, which uses a pair of rotors to create negative pressure or vacuum. Now, let's get right to how this supercharger works. The supercharger starts working when the engine is turned on because the crankshaft rotates, and this rotation is used by the supercharger. By connecting a pulley directly to the crankshaft, the rotation can be transmitted to the drive pulley located in the supercharger unit through a belt called a serpentine belt. Then, the rotation on the drive pulley is further transmitted through a shaft to a pair of rotors, which are the main components of the supercharger. However, before the energy reaches the rotors, we will find a pair of gears commonly referred to as the overrunning gears. The function of these gears is to rotate the two rotors more precisely to avoid friction between the rotors. The reason for this is that if the rotational energy is transmitted directly to the rotors will rub against each other extensively along their surfaces, resulting in greater frictional forces. This, of course, leads to a higher load on the motor and also to wear or erosion of the two rotors because there is no lubrication in the rotor area. Next, as the rotor begins to rotate, negative pressure or vacuum is created. Then, as we step on the accelerator and begin to increase engine speed, the negative pressure increases, the throttle body opens, and air from the atmosphere is more freely drawn toward the rotor. As a result, the air passing through the rotor is compressed. However, there is a problem at this stage because the forcibly compressed air will experience molecular friction, causing the air molecules to heat up and expand. As a result, the air cannot be compressed to its maximum. To solve this problem, a special radiator, commonly known as a charge air cooler, CAC, is installed between the intake manifold and the supercharger unit. This radiator is responsible for returning the temperature of the air that passes through its grill, or more precisely, through its tubes and fins. The air molecules that pass through this grid automatically shrink and become denser. Then, the required air pressure along with more fuel is introduced into the combustion chamber, creating a greater force to turn the engine, and the exhaust gases are expelled through the exhaust pipe. Okay, that's the detailed working algorithm of a supercharger that we can provide. For those of you who want to add or correct anything in our explanation, you can write it in the comments below. Now let's try to explain it again more briefly, so that others can understand it better. The supercharger begins to function when the engine is started, with the crankshaft that rotates when the engine is started being directly connected to a pulley located in front of the engine. This pulley is responsible for transferring rotation to the drive pulley of the supercharger through a belt called a serpentine belt. The rotational energy then continues through a shaft to the gear section, which functions to rotate both rotors. When both rotors begin to spin, suction power is created that draws air from the atmosphere and compresses it within the housing. This compressed air is then cooled again using a water cooler radiator. Once cooled, the air is compressed once more in the intake manifold to the required pressure before being supplied to the engine, along with more fuel, thus becoming a significant power source for the engine. Finally, the remaining exhaust gas after the expansion is expelled through the exhaust pipe. This is a general overview of the supercharger system. However, it is important to note that if a supercharger is applied to a standard engine, engine adjustments are also required. the process is analogous to that of applying a turbocharger. It begins with the adjustment of compression in relation to the boost generated by the force induction, as well as the ideal compression requirements for the fuel to be used subsequently. This is followed by the adjustment of the expansion timing and the amount of fuel supply. Finally, the replacement of some moving parts with stronger ones, such as pistons, piston rods, and others, is necessary to accommodate the increase in power. This approach is designed to ensure that the engine's durability can accommodate the increase in power. This is the explanation that can be provided about the supercharger, particularly the model that was discussed. If you found this video informative, we request that you click the like button and share it with others. Additionally, we encourage you to subscribe to our channel so that you do not miss any updates. By doing so, you will help us to grow. We look forward to your continued engagement in the next video. Thank you for your attention.